Hello there, and welcome to another lesson for Pre-Calc 30. Today we're going to look at graphing radical functions. So the first thing we're going to do is practice graphing radical functions using a simple table of values. So use a table of values to sketch each graph, and then we're going to state the domain and range of each one of these functions. Now, when I look at these functions, I don't like to try to state the domain and range just by looking at the function. Once I see the graph, the domain and range seem much more obvious to me. So let's go ahead and get started. Now, one restriction that we might notice right away is that x cannot be a negative number because we are not taking the square root of something that's negative. So let's start at 0. If x is 0, y equals the square root of 0, and of course the square root of 0 is 0. Now here we have to choose our x values intelligently so that we don't need to use a calculator. We don't want to if we don't have to. So let's just choose values of x that are perfect squares. So if we choose 1 for x, then we know that y will also be 1. And if we choose 4 for x, which is the next perfect square, we know that y will be 2. So let's just move on to the next simplest perfect square, and then we should have enough points to plot this thing. So the next perfect square is 9, and its root is 3. Okay, so let's start with this value, 0 and 0. That's a point there. We also have the point 1 and 1. Then our next point is x is 4, 2, 3, 4, and y is 2. And then finally x is 9, 5, 6, 7, 8, 9, and y is 1, 2, 3. Connect those points with a smooth curve. And this is the graph of root x. Now, when I look at this, in terms of the domain and range, to me, now that I have this graph drawn, it's really easy to see. In terms of the domain, this is always the allowed x values. So the allowed x values, if you look at this, we don't have any negative x values. So our domain would be anything that's 0 or up. And similarly for the range, this is even more difficult to see just from the equation without graphing the function. But if we do graph the function, it's very plain to see now that the range is only going to give you positive values of y. Nothing will be below the x-axis. So again, the range, our variable is y, and y must also be greater than or equal to 0, and it's also an element of the real numbers. Alright, so that's the first one done. Let's erase this, maybe a little faster than that, and move on to the next one here. I'll graph in a different color. So this is y equals the root of x minus 2. Now if you know a little something about transformations, which I know that you already do, you can probably make a prediction about how this minus 2 is going to affect the graph that we have right here. But let's go ahead and see. Now, again, we want to intelligently choose x values that will give us perfect squares, so when we take the square root, we end up with an integer value of y. It makes it much easier to plot it on our graph for us. So basically, whatever's under the radical sign, we want to end up as a perfect square. Okay, so x minus 2 is a perfect square. Now, if we want our first perfect square to be 0, x minus 2 equals 0, then you solve this simple equation and you get x equals 2. So if x equals 2, then in here we have the root of 2 minus 2, which is the root of 0, which will give you a 0 value for y. And you can keep going with that trend. That is not what I was looking for. There we go. You can keep going with that trend with the rest of the perfect squares. So for example, you want x to be the next, or you want, sorry, x minus 2 to be the next perfect square, which is 1. Solve this again and add 2 to each side, and the next value of x would be 3 to give us a y value of 1, which is the square root of 1. And then next we want x minus 2 to be 4, because 4 is a perfect square. So x is 6. 6 minus 2 equals 4. Take the square root of 4 and we get 2. Now you'll notice the pattern right away for the y value. Since we keep choosing the next successive perfect square, we're just counting by ones for the y's. And our next perfect square would be 9 here, and add 2, and x value would be 11, which isn't quite going to fit on our graph, but that's okay. So let's start plotting these points now. When x equals 2, y equals 0, so now that point is right here. So right away you'll notice that basically our vertex, or our original point, has shifted 2 over. This is consistent with what we know from last unit, where we have an h value of 2, and h of course always represents a horizontal shift, and since h is positive because it's defined as a negative value in the equation or in the formula, h is positive, that means a shift to the right horizontally. So now we can take every point and just shift it 2 to the right, and we should find that it matches up with what we had in our table. So the point 1, 2, 3, and 1, yep, that's exactly what we had. Shift this one right twice, and it should give us 1, 2, 3, 4, 5, 6, and 2. Yep, exactly what we predicted. Okay, shift this one 2 to the right, which just doesn't quite fit on my graph, but it would be right there. And here is our new curve. Okay, so y equals the root of x, and then subtract 3. So again, choose values of x that are perfect squares. So this is simple, and this will be easy this time because we only have x under the radical sign. So we can go ahead and choose 0, and the root of 0 will give us 0, and then subtract 3 to get y. So y will end up being negative 3. Okay, so our next one that's a perfect square is 1. Root of 1 is 1, and 1 minus 3 will give us negative 2. Okay, so the next perfect square we can choose is 4. The root of 4 is 2. 2 minus 3 will give you negative 1. And again, you'll notice that we're counting by ones and getting greater by a single digit each time in the y column. And finally, if we choose 9, the root of 9 is 3, and then we'll do 3 minus 3, and that will give us the 0 that we find here. Okay, so let's see what happens here. 0 and negative 3. So x is 0 right on the y-axis, and go down 3, and this is our new point. And again, you can predict, because this is a k value, and it's the same type of transformation that we worked with in the last unit, every point from our original graph is going to be shifted down by 3 units. So you can just do that, and you'll find that it should line up again with the points that we predicted right over here. 1 and negative 2, so we go 1 and down 2, and voila, it lines up. Pretty straightforward. So again, shift this one down 3, shift this one down 3, and they are consistent with what we predicted in our table of values right here. So this is the graph of root x minus 3. Poor space management, doll. Oh well. Oh, and now the domain and range. I apologize, I forgot to do it for the last one. But we'll do it for this one and should get a pretty good picture. So for this blue one, the domain, now the domain is any x value that's allowed. And again, we are not allowed to use negative x values because we don't want to take the square root of a negative number. So we allow positive ones or anything greater than 0. So x such that x is greater than 0 and x is an element of the reals. That's done. Now the range. The range, we are actually ending up with some negative y values. But no matter what we choose, since we're not allowed to go lower than 0 for x, we will never fall lower than negative 3 for y. So if this thing continues on forever, it will never go below this point right here. It'll never go down here. So our y value is always going to be greater than or equal to negative 3. It'll never dip below. So y, such that y is greater than or equal to negative 3. And again, it can be any value that's greater than or equal to negative 3. So y is an element of the reals. And we're done. Now I'm hungry, so I'm just going to take a quick burger break, and I'll be back with you to finish the lesson in a little bit. Delicious. God bless Dairy Queen. Okay, I'm back. Now we're going to look at graphing radicals using transformations. Now this is the new general form of our equation when we're looking at radicals. So you'll notice that we still use the parameters a, b, h, and k, just like we did for our regular functions from Unit 1. And they actually still mean all the same things. Okay, so a is a vertical stretch, b is a horizontal stretch, h is a horizontal shift, and k is a vertical shift. I've made a little note here, refer to page 65 regarding the effect of each parameter. It's just a review of what each one does. Alright, so here we're going to try graphing a new function, y equals 3 times the root of negative x minus 1. And we're going to do this just by applying these shifts to the regular graph of root x. Now we can apply all these shifts one by one and see how it affects our graph. So as we indicated in the last unit, the shifts that we have to do first are the reflections and the stretches. So right now this negative sign, this indicates that b is negative 1. That means that this is a reflection about the y-axis. So we can take this graph and we can reflect every point directly to the left side instead. So it will still have the point 0 and 0, because you can't reflect that. This one will be reflected here. This one, where it's 4 and 2, will now be negative 4 and 2. And then 9 and 3 becomes negative 9 and 3. Okay, so this is what it looks like with just this shift applied. We're still not done. We still have to apply this one and this one. So let's take a look at our stretch here. Now this is outside of the radical sign, or outside of the actual f of x. Now where we normally have the point, let's use our new points, where we normally have the point negative 1 and 1. We are now applying a vertical shift by a factor of 3. So this point can be mapped to now be this multiplied by 3, which will give us 3. So we'll have negative 1 and 3, which puts us right here. Sorry, I'll use a different color. Go back to Old Faithful here with our purple. Alright, and then here this point is negative 4 and 2, and our vertical stretch by a factor of 3 will now put us at negative 4 and 2 times 3, which is 6. So negative 4 and 2, 3, 4, 5, 6, which will put us right here. This one is negative 9 and 3. It will now become negative 9 and 12, which would put us 2 off of my grid, somewhere right up here, and we end up with this step. Whoa, that was awful. Oh well, you get the point. And we're still not done, so let's just move on and pretend that that was actually a little better than it is. Alright, so we've applied this now and this. Now it's time to apply our last one, which is the h value. And what does the h value do again? That's right. It's a horizontal shift. And h here is actually positive 1 because x minus is the same as here, x minus. And you notice that h, we've just replaced h with a 1. We haven't replaced it with a negative 1 because that would make this positive. So h is 1, which is a horizontal shift to the right. So let's take our new graph here, move it to the right. So 0 and 0 becomes 1 and 0. Negative 1 and 3 becomes 0 and 3. And negative 4 and 6 becomes negative 3 and 6. And any other point, we just shift it 1 to the right. And we draw our new curve. And I'm sorry about the difficulty of seeing the yellow. I thought it would be a fun color and cooler than this, but it really kind of disappointed us all. Okay, and now the domain and range, let's compare it to the domain and range of our original function. So the final domain and range, well, if you look at the domain, any x values that we're allowed to use, this has to give us a positive number underneath the root sign, which means negative version of x minus 1 has to be greater than or equal to 0. So negative x plus 1, if we distribute this negative sign in there, has to be greater than or equal to 0, which means that negative x has to be greater than or equal to negative 1. And when we divide by negative 1, we have to flip this sign over, which means x has to be less than or equal to positive 1. And again, we can see this in our graph right here. We cannot choose a value of x that is greater than positive 1. So we can choose positive 1 and anything less than that. Okay, so our domain is x such that x is less than or equal to 1 and x is an element of the reals. Alright, now our range. Again, this is easiest to do just by looking at the graph. Once it's finally graphed, we can just look at it and figure out our range. And again, nothing goes below 0. Everything's above, but 0 is counted. So our range, now, sorry, that massive burger gave me hiccups, I guess. But man, was it worth it. Okay, so our range y such that y is greater than or equal to 0 and y is an element of the reals. And we're done. Awesome. So let's move on to the last function we're going to look at for today. And it is this one right here, y minus 3 equals the root of 2x. So let's get this into a form that's a little more familiar to us by solving for y. So all we have to do is add 3 to both sides and we end up with y equals the root of 2x plus 3. Now this 3 is outside of the radical sign. So whereas our shift before was underneath, included in the brackets with the x, that indicated an h, our 3 now indicates a k. So this is going to be a pretty simple one, so let's apply our stretch first. This is a horizontal stretch, now by a factor of 1/2, because remember it's always 1 over b, and b is 2 in this case. So our horizontal stretch, so let's start with, again, with our regular graph of root x, which is this. Maybe I just won't bother drawing the curves in anymore because they're just so horrible. They make it look sloppy. Alright, and let's apply our shift. So a horizontal stretch by a factor of 1/2. So normally we have the point 1 and 1. Now horizontal stretch by a factor of 1/2 affects the x value. The y value will stay as is, and this one will be affected by a factor of 1/2. So 1 now becomes 1/2 and y stays as is. And we choose this point. It is 4 and positive 2. And again, the y value stays as is. The x value will be affected by a factor of 1/2, so it becomes 2 and 2. And this point, finally, this is 9 and 3. And the y value will remain the same. And half of 9 is 4.5, or just 9/2. And y remains at 3. Okay, so we can plot these points. So we now have 1/2 and 1, which will put us right here. 2 and 2, so 1, 2, 1, 2, which will put us right here. And then we have 9/2, which is 4.5, and 3. So 1, 2, 3, 4.5, and 3 would put us right here. And if we kept going, 0 and 0, of course, is still a point, because you can't multiply by a factor of 0. Our curve would look something like that. Yeah, that one wasn't so bad. A little better. Alright, so that's only the one shift. We've only applied this one so far. So we still need to apply this one right here. And you know that k represents a vertical shift. This is a vertical shift of 3. So if you wanted to map it, our new points of 1/2 and 1, a vertical shift of 3 will leave x unchanged, and this one jumps up by an additive factor of 3, so it becomes 1/2 and 4. And again, you can just go to any point and go 1, 2, 3, count 3 up, and away you go. 1, 2, 3 will put us right here. This one, 1, 2, 3 will put us there, and here, 1, 2, 3 will put us right there. And we're done. So let's quickly clear some space, look at the domain and range, and then we're done for the day. So the domain, again, this is easiest just by looking at it, in my opinion anyway. The domain, what x values are we allowed to choose here? Well, we're allowed to choose any x value that is greater than 0. Again, if we chose a negative x value, you multiply it by 2, and under the radical sign becomes negative, which we can't do. So again, just look at the graph. X values that are positive are allowed, and 0 is allowed too, so we include it. So x such that x is greater than or equal to 0, and x is an element of the reals, and we're done. And then look at the range. Now, if we can't choose any x values that are less than 0, we will never fall below this point right here. So y will never be 2, 1, 0, or anything negative here. And in fact, it bottoms out at 3, so y such that y is greater than or equal to 3, and y could be any of those values greater than or equal to 3, so it's an element of the reals. And we're done. So that's it for today's lesson. I hope that was helpful. I'll see you in class tomorrow.